So let's take a look at the methods and commands that we need to update the elevator height. So to update the elevator height, we need the voltage. So where does that voltage come from? Well, you have the PID controller, which is a feedback controller, and you have the elevator feed-forward controller, which has another voltage. So you need to sum those voltage up. And that's what we are going to do. Void, and I'll call it reach go. And we take the go, which should be the height that we want. So what I call reach go is our arm also use reach go, so yeah. So we need the volts output. Okay. So first is our feed forward. And I think this one it's like this one, it only takes the velocity, and it's like continuous control. Is it continuous? I don't think so. Yeah, I would say our acceleration is not 0. Or actually, so this one. So if you're using the calculate with one velocity, and that means your acceleration should be 0. So it's like constant velocity. But we are not doing that. So what we are going to use is with velocities. So I take the current velocity and next velocity. Yeah. So it's like this discrete control. So it's like just not continuous. So our current velocity, well, look at that. So velocity meters per second. And our next velocity, that's what we need to get from our PID controller. So controller, we don't need calculate. Let's get set point. And we need the velocity. So that's our next velocity. And then after the feed forward, we need the voltage for the PID controller. So M controller, and this time we need to calculate. So what we are going to use, since we have a goal, right? We have our desired height. So we're going to use the first one, which take the measurement, which is the current height, and our goal, which is our set point, the height. So the measurement is get position meters, and we'll just put the goal here. Another thing is we need to be aware that the voltage outputs, it should always be the safe voltage for the motors. Like, it shouldn't exceed the high voltage. So we're going to set some limits here, and what we are going to use is math until dot clamp. Wait, it should be dot. No. So math util dot clamp. So we need our value and our low limits and high limits. And what we are going to take is double. So our value is what we have here. So like that. Okay. And our low limits, I'll just put like -7 volts. And our high limits, I'll just put 7 volts. And the parenthesis, yeah, okay. And then after we have the outputs, the volts output, we need to set it for the motor. Motor set voltage output, volts output. Okay. And now we have our voltage output, and we want everything to be in command-based. Since here we're using command-based programming, so we need to set the command, which we can call it setGo. So since we're using command-based programming, we also need to convert it to command. So public command and setGo. And we need to return something. Yeah. Return, and I'll use run. So we're using run because we want to keep setting the voltage to a certain amount instead of just run once. And runnable action. So here I'm going to use the lambda expression. So the methods we are going to use is reach go. Ta-da! Okay. And we have the setGo. Shall we just put it? No. Okay, so if you think of that, you have a command called setGo, and you just keep setting the voltage to that amount. And it'll just keep running. But when will it so it'll just keep running, but when will it stop? So that's why we need a condition to interrupt it. Command, and I'll call it set elevator height. And double height. Yeah, let's do that. And it's return. So basically, it's returning the setGo, but with an until, we add a condition to interrupt the command, or like to end the command when the elevator reached that height. So since setGo is already a command, instead of using run, because the reach go is a method, we'll just use setGo here. Height. And we are going to use our until. So until the elevator reached that height. So we are going to add something to check the height, if it is around that height. So we'll have a new boolean, and it's checking around height. And we take the height, the desired height that we want. And what we are going to return, is we are using the math util dot is near. So with this one, we're checking if it is near. So we are going to use the is near. And what we need is the expected, which is our goal, and the actual, which we should be able to get from our get position meters. Yep. And what else? Okay, let's do it first. So we'll put in the expected, which is our height. And our actual is get position meters. And our tolerance. So we'll just set up a constant for that. So 1 inches, which is, I don't know, yeah, so 1 inches and it's in meters. And that's our K tolerance. So what if you want to have multiple tolerance? So we'll just, maybe I should set it to default. So default tolerance. And that makes sense. Then we have multiple other tolerance. So same headings, double height. We're taking the height and we are taking the tolerance that we want. So return the same. So let's see. So it should return the same thing. But what we can do is near tolerance. So actually, instead of typing everything out, here we can call the around height with 2 parameters, with our height and with our default tolerance. Yep. So now let's go back to set elevator height. So until, and it needs a Boolean supplier. So we're going to use the lambda expression again. So we are using around height, and we'll just go with height. So we are using the default tolerance. And yeah. So for our robot container, we need to set up an instance variable. So private final elevator subsystem elevator, and next, inside our robot container, the constructor, we need to set our default command like those. Elevator set default command, So what we are going to use is the set height, set elevator height. So it will be initialized to the height of 0. And then inside our configure bindings, we'll put our buttons that we want to control our elevator height or to link to that command. So driver controller, button output, button 1, while true, and command. So the command will be elevator dot set elevator height. Let's put 4. And let's see. So I just run a simulation and it seems that so the windows just pop up and close itself, so we have some problems. And yeah, let's take a look. Oh, elevator sim. So let's try this one. Putting another 0.0 and well, at least it shows something and it's not closing the window. So I'll first briefly explain how to set up the keyboard for the buttons. So if you see here, so we have keyboard 0 and we put it for the joystick 0, like put it here, and we have the and we have the buttons. So if you go to DS and click keyboard settings and go to buttons, and you can add how many buttons, whatever you want. And for button 1 we have Z. So oh, did I click teleop? Okay, so let's see. Where it's not showing anything. So I believe we forgot. Yeah, we didn't update the side view. We didn't update our visualization in our constructor, so that's probably why. So smart dashboard, put data, side view, and remember we put our mechanism 2D in our constants file. So constants side view, and this should be, I don't know, let's see. So teleop, ooh, yay! Yeah, so the red thing is the elevator, and when I click the button, so you can see here, when I click the button, but the elevator still needs some tuning, so yeah. And with our arm, so also this one, we should put the carriage, yeah. So let's see. Well, it's showing the blue arm, so okay, yay. So yeah, the arm is attached to the pivot point, so that's good. So I'm also going to talk a little bit about the command group. So if you notice, we are using command in our subsystem, and the command group is like we're putting multiple commands from different subsystems together, like in a group. For example, if you want to score a game piece, like you're using elevator to reach that height, and you're using arm to reach an angle. And that's where we can put commands together in a group. So in our system, we have system and subsystem. So we created our system for all these command groups. And yeah, so we have a system and we create an instance variable for each subsystem. And yeah, in our constructor, we give it a value. And I'll talk a little bit. I'll just use lgload as an example. So lgload, so it's a command group, and it uses like set elevator height command and set arm angle command, and we link those commands through along with. That means you're trying to run two commands at the same time, or like and then. This is like after you run this, and then you run this, and then you run this. So yeah, and that is called, and along with is called parallel command group, and then it's called like sequential command group. So yeah, and we also use like until, yeah, like wait until. Okay, so until, we use that to add a condition that we are checking. So if elevator is around this height, then stop all of these, and just run the second, and just run the next thing. And commands wait until, it's also like setting the conditions that we wanted to check. Yeah, and for the robot container, it's like also the same as the elevator subsystem. You're like create a new instance variable with all the values you need, which we declared it here. And inside the robot container, oh, this is just our ARM default command, so never mind. And we create a new button for our new command, which is loading system.lgload. So for our command group, so we have the second button, which is our button X, and we so if you notice, it sets the elevator height also, and also the arm height, the arm angle. So yeah, that's a brief demonstration of the command group. So that's it for the elevator simulation. So I would recommend you guys to read the actual documentation from WPI-lib so that you can get a better understanding of what's happening. And we still can do lots of improvements on this simulation, like tuning, yeah. And if you guys have any questions, just leave it on the comments down below. And stay safe, and I'll see you guys next time. Bye!